Okay, today we're going over 0, 1 functions. Something to keep in mind is in the past, this was called 0, 2. So the solutions might say 0, 2. So functions are a relationship with one or more variables where each input has a single output. So basically we plug in some value, typically we call that input value x. So we plug in x and we get an output of y. Sometimes we call that f of x. So this is all about inputs and outputs. Something to keep in mind is that domain is all x values. Range is all the y values. So it's just like a group of, these are possibilities. So when we're working with functions, kind of the key point is you have some value that you turn into something else. Some input that you do something, get the output. So what this is saying is I'm going to take some function and I can input something for x. And then what I have to do is I have to take that number times 3 and then add 2 to it. So when it says, what is f of 5? This is just saying, take 3 times the number plus 2, and the number we're going to use is 5. Because the 3 comes from here. So this type of problem is called evaluate. Because we're just plugging something in. We're just using substitution. So what is 3 times 5 plus 2? Three times 5 is 15 plus 2, so I get 17. So with this specific function, if I plug in 5, if I have the input of 5, I get the output of 17. Instead of giving me the input value, this one is giving me the output. So it's saying, what do I need to input to get back 14? 14 is the output. So that's where you're going to say, okay, 14 equals 3 times some number plus 2, and we work backwards to figure out what to plug in. So I'm going to subtract 2 from both sides, and I get 12 is equal to 3 times x, and then we divide by 3 on both sides. So we get 4 is equal to 1x. Well, I don't have to write the 1, because 1 times anything is just itself. So x is 4. What that tells us is if I plug in 4, if I input 4, I get the output 14. So this time the 4 is the answer. This is a solve problem, because we're solving for the input versus evaluating the input. So this one, our function is we're going to take some input value, multiply it by 3, and then add 2. So the first set is telling us to input 2, input -3, and then we'll input 1/2. So whatever we're doing, we're taking 3 times the input value plus 2, and we input 2. So 3 times 2 is 6. 6 plus 2 is 8. So when we input 2, we get an output of 8. Go ahead and try the -3 on your own for a minute. With the -3, we're doing that same process. We're going to take 3 times whatever the number is plus 2. So when we take 3 times -3, that's -9. And then we add 2 to that and get -7. So when we input -3, we get an output of -7. When we input a fraction, we get 3 times 1/2 plus 2. Now, I know you guys love fractions. That was sarcasm. So I don't necessarily care how you deal with this as long as you do it. I don't care if you use a calculator to do this. I don't care if you have some method that's like really weird and random and I've never heard of, and that's fine. You just have to do it. I don't care how. The way I do this is I rewrite it as 3/1 times 1/2, because 3 can be written as 3/1, plus 2/1, and I'm going to multiply that by, I don't know if it copied it down, it did not. Let's see if I can move this up. I'm going to multiply it by 1. 2 divided by 2 is still 1. Because then when I multiply straight across, we'll move it back down later, I get 3/2, because 3 times 1, 1 times 2, plus 2 times 2 is 4, 1 times 2 is 2. So now I have 3/2. Yes. No. Plus 4/2 is 7/2. So that's my answer, is the 7/2. To solve, that's where we have the 8 is equal to everything else, because we have to figure out what x is. We have to figure out what to plug in, what our input value is to get 8. So we undo things. So I'm going to subtract 2. So I get 6 is equal to 3x. And then we're going to divide by 3. And so I'm going to write this up here. I get 2 is equal to x. Because if I input 2, I get back 8 as the output. Now, because this function hasn't changed while doing this, I want you to notice that you didn't actually have to do it on this specific example, because we already plugged in 2 and got 8. So you could have said, well, I already did that. I just did it the other way. Or you could have worked through it. That's fine too. Okay, this last one, you can plug in something that's not a number. You can still input something like this. So we're going to do the same process. 3 times whatever's in the parentheses plus 2. So I have an m plus 1 in parentheses. So I have to, what this is saying is to multiply 3 times m plus 1. I don't know what m plus 1 is. So the way that we multiply this is we multiply the 3 times m and the 3 times 1. So I'm going to take 3 times the m and 3 times the 1. And then I add 2 because it tells me to add 2. So I simplify this and I get 3 times m is just 3m, because I don't know what m is. 3 times 1 is 3. And then I still have the 2. Now I can add the 3 and the 2, so I get 3m plus 5. So if I input m plus 1, I get 3m plus 5. For this one, we have 2 different functions. And so we're not going to call them f of x because we don't necessarily want it to be f of x every time. That's just representing our output value. But we're going to use k of x and m of x. Now, this is helpful to use different letters because that tells us which one to use. So on the problem, what is k of 4 plus m of negative 2? K of 4 tells us to use the k function, so the top one, and to replace x with 4. So we're going to figure that out first. So k of 4 is going to be 2 times 4, because that's our number that can change, minus 3. So I'm going to replace that with a red 4. So I have 2 times 4 is 8. And then I have to subtract 3. So k of 4 is equal to 5. When you input 4 into the k function, you get an output of 5. Then I'm going to do that same thing, but with the m function, and I'm going to input negative 2. Then we will add them together. Okay, so let's do the m function. I'm going to use green, why not? So m tells us to use the bottom one. So this is slightly different. The parentheses are here, and it's not in the last one. So this wants me to multiply 2. It wants me to take the number and subtract 3, then multiply by 2. Whereas the first one wanted me to multiply 2, then subtract 3. So now we're going in a different order. So I'm going to figure out what m of negative 2 is. So m of negative 2, I'm going to have to take 2 times the number minus 3. So I'll plug that negative 2 in. So this tells me to take 2 times, what is negative 2 minus 3? Negative 5. And then I just multiply those together. So m of negative 2 is equal to negative 10. So I've done 2 kind of separate problems. And then the whole thing says to add those together. So when I do this whole thing, I take 5 plus negative 10, because the 5 is from that k of 4, and the negative 10 is from the m of negative 2, and that gives me negative 5. So that's my answer. So negative 5 is the output of the whole thing, but I had to do inputs and outputs separately first. And then this next one is saying to take 2 times whatever we get from k of 4. Well, we already plugged in 4 into the k function. What did we get? When we input 4 into the k function, we got 5. So I can replace that with a 5, because we already figured that part out. So now what is 2 times 5? So my answer on that one's 10. I'm going to give you another minute to write it down, and then I'm going to take some questions and maybe go over it again. When you're dealing with a graph, this is just a different way of representing a function. We're still doing the exact same thing. It's inputs and outputs. I don't expect you to figure out the process behind what's happening yet. We're not going to do that today. But what you need to recognize is just points on a graph are a series of inputs and outputs. You input X, you get back Y. That's why you have points represented with X, Y. So when it says M of 3, it says to look at the m function, which is the only one on this graph, and input 3. So when we input 3, 1, 2, 3, to find the output for this function, I have to look up, and there's nothing, and down, there's a point right here. So this point is 3, -4. Because that's the output or the y value for the function. So m of 3 is -4. So you don't have to do any of the algebra stuff. You just have to look at the graph and see what point it has. Where does it have an x value of 3? So this next one, we're going to look at 0, and if you look closely, it doesn't match up perfectly, but we're going to force it to. So when I input 0, I get -2. Because that point is 0, -2. I want you to try 7 and -3 on your own. So the 7 is right here. That point is 7, 0. So when you input 7, you don't go up or down anything to get to the graph. So it's 0. -3 is over here. So I go all the way up to 5. So when I have an x value of -3, I have an output of 5. The y value is 5. We have to approach the y values a little differently. So I need to find where the output is 2. So I look on the y-axis and say, okay, that's 2. I'm going to look left and right to find what x values would work. An x value of -2. So -2 would give me an output of 2. Also, 8 would give me an output of 2, because that's that point right there. So there are 2 answers here. It is possible that 2 different input values will give you the same output. Doesn't always happen, but it is possible. So on this next one, we don't have 2 options. Or no, we do have 2 options. Try this one on your own. Find where you have a output of -3. So you have an output of -3. So this is -3. So here on the graph and here on the graph. Those x values are 1 and 5. So we have x equals 1, x equals 5. If I use either of those as inputs, I will get the output of -3. Basically, I've given you a graph with 3 different functions, and I have them color-coded, so blue, green, and red. A of x is the red function. B of x is the green function, and C of x is the blue function. So the reason why I want to kind of talk about these all together is if it says A of 0 right here, that means that we're going to input 0, but we're only inputting it into the A function. So the only one we care about is the red, not the blue or green. So I'm going to see where I have an output of 0 right here. So when you input 0, the y value is -5. So when you input 0, you get back -5. I don't care that on the blue and the green graph at x equals 0, I get something else, because I only care about the red one, the A function, because it says A of 0. Where it says B of 4, That's where I'm going to look at an x value of 4, but I only focus on the green function. So I'm not going to look at the red or the blue. I go up and see that this point is 4, and then we go up 3. So I input 4, I get back 3. So the output is 3. And then this one, with the c of x is equal to negative 3, so if I'm looking at the negative 3, I go to negative 3. 1, 2, negative 3. Right here. And I look at that point, because that's where the blue function is touching negative 3. Technically, this is in between two whole numbers, or two integers. And so if I look 1, negative 2, negative 3, it's the x value is between negative 2 and negative 3. So I'm just going to say that it's negative 2.5, because that's about halfway between. And then that's that answer. So where they are equal is just where they intersect. So right here and here. So those 2 points are negative 5, 3 and 0, 3. But you only need to tell me the x value. If you include the whole point, fine. But you really only need negative 5 and 0. Because if I input negative 5 into both functions, I'll get the exact same thing. And if I input 0 into both functions, I get the exact same thing. Let's get a different color. Where does a of x equal c of x? So the red and the blue. Do they intersect? So there's a couple ways to indicate that there's no solution. You can write out no solution. You can write out does not exist. Or my favorite, DNE, does not exist. I like that one because it's less to write, but I would accept any of them. It's just, there's not an x value that works for that because they don't ever intersect. When does b of x, or when is b of x greater than c of x? So let's look at things as we're going. We read graphs typically from left to right. So if I'm looking at this point, this part of the graph is above the green one. So as we're going through, the blue one is above the green one. Then as we're going through, it switches, and the green one is higher than the blue one. And then the green one is lower than the blue one. So when is green, or b of x, when is it above the blue function? For what x value? Well, these ones, the blue one's higher. These ones, the blue one's higher. So it's the middle piece that is going to work, because in this section, the green one is greater, or higher, or has a larger output value. So what x values are right there? X is negative 5 right here, and x is 0 right here. So negative 5, 0, that's listed not as a point, but as an interval. You could also write out negative 5 to 0. That would work as well. But when your x's are negative 5 to 0, the b of x, or the green function, is going to have a higher output than the blue. Question. Anyone need more time to write it down?